On these problems, we're going to solve them graphically. We're going to have Desmos at our disposal. And so we're just going to identify whether or not there are one solution, no solutions, or infinitely many solutions. And we can do it algebraically, but in this context, we're just going to get the visual model. So one solution would look like the two lines intersecting. No solutions looks like the two lines parallel. And infinitely many solutions looks like you have the line of the first equation, and then you go ahead and graph the second line, and it perfectly coincides on top of that first line, and that would be infinitely many solutions. So we're just going to go ahead and type this expression, this system, into Desmos. And so both equations in standard form. Here we go. Let's type it in. And so when we graph it on Desmos, what you're going to see is essentially one line. But if I take a look at unclicking one line at a time, you'll see in that same spot the blue line. Now I click the red line, and it goes right over top of that blue line. They're perfectly coinciding lines, exactly on the same location. So even though they're a different form of a line in standard form, multiplied by a factor, they are the same line on the graph. And what that means is both the equations are the same. And so for us, that means there are infinitely many solutions. This is the scenario we're looking at. Let's try another one. In this scenario, we have different expressions. So we're going to type those into Desmos and just get a look at what scenario, which of these three options we're looking at. So over in Desmos, we see these two lines intersect. They're going off. They have different slopes is another way of noticing it. And so if we zoom out, you see them really spreading out. Doesn't matter how far you zoom out or in. Trying to drag it over here. The intersection is what we're looking for. That coordinate right there, -1, -3, is the solution that we would find by elimination. That is the one solution we would find by elimination because there's only one solution of two lines intersecting. So there is a single solution, one solution. That's what we select for this system. We'll take a look at one more system and see what it looks like. As we plot these into Desmos, we will find these are parallel lines. When lines are parallel, they will never intersect. No matter how far you zoom out, they will never actually cross. If you zoom out far enough, it'll look like they're one line, but that's only because we're zoomed out too far. They never actually do intersect. So that means there is no solution of intersection to the system. So we select no solutions. Now that's how you do it graphically. Algebraically, we would have done elimination for each problem. Elimination would yield, for infinitely many solutions, 0 equals 0. What happens is the variables would cancel and you get 0 equals 0. For no solutions, we'd get 0 equals something that wasn't 0, like 5. It would just be 0 equals some number. And then one solution is just your coordinate. You get some x comma y. That's the most traditional way that an elimination problem works out for us. But for our context here, we're talking about graphing.